Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera. So we go to chapter 6. The topic is predictive analytics for prediction. So the content of this slide is introduction to regression, the simple linear regression for one independent variables, and we also learn the multiple linear regression for two independent variables. Introduction to regression. What is regression? Basically, regression is used to predict the value of dependent variable and to explain the impact of changes in an independent variable. So the dependent variable is the variable that we wish to explain, and the independent variable we use to explain the dependent variables. And two types of regression linear model. First is simple linear, second is multiple linear that we cover in this chapter. Right, simple versus multiple linear regression. So we go to the example here, the sales, the analysis of company profit. Okay, so the simple regression here, we use one dependent variables, which is the number of sales. The number of sales is influenced by the promotion. The promotion may be from Facebook. Okay. Right. Extension of simple regression, we go to multiple regression. Okay. We also have one dependent variables, which is the number of sales. And since we apply the multiple regression concept, so we use two independent variables or more. For this case, we only consider two independent variables that influence the sales. First is Facebook promotion. Second, maybe promotion through Instagram. This is an example of simple versus multiple linear regression. Right. The simple versus multiple linear regression, if you see the graph here, the X versus Y means in the simple linear regression, we only have one independent variable that influence the value of dependent variable. But for multiple linear regression, we have two independent variables that will affect the dependent variables. So changes in dependent variable Y is affected by changes in one independent variable X in simple linear regression. And changes in dependent variables Y is affected by changes in two or more. For this case, we only consider two independent variables, S1, S2 to Sk. Okay, suppose we have 5 independent variables, so K equal to 5. Right, for this case, K equal to 2. Right, this is the basic formula to define the regression model. So we have Y, dependent variable, equal to B0. B0 is the intercept value. And plus B1, X, B1 is the slope value. X is the one independent variables. Since we use simple linear regression, and epsilon is error, or also called as residual. Okay. So on the graph, when we plot the straight line here, for Y equal to B0 plus B1X plus error, so we will get the intercept value here. which is B0. And the B1 is the slope value. Okay? And also the error here. But if we define the predicted terms here, the predicted simple regression model, so the Y change to Y cap. Yeah, Y cap. Y cap means the estimated or predicted Y value, which is B0 is the intercept and B1 is the slope. But here we remove error. We remove error for predicted predicted model, since the error we assume have a mean of 0. Okay. In order to calculate the slope value and intercept value, we need a formula. This is the formula for calculating intercept slope value and B0 value or slope value. So first we go to B1. We go to the slope value, then the value of B1 will be transferred into equation B0 right now. So interpretation of slope and intercept. Basically, B0 is the predicted average value of Y when the value of S is equal to 0. Okay. From the graph here, you can see. Okay. When S equal to 0, at this point, S equal to 0, you get the B0, the intercept value. Okay. And B1 is the predicted change in average value of Y. As a result, a 1 unit change in S is the meaning of the slope value. Okay, we go to the example here. Two variables we consider is house price and square feet. Okay, so we go to the problem statement. A real estate agent wishes to examine the relationship between the selling price, home, and its size, measured in square feet. So now, first, we need to define what is the dependent variable and what is the independent variable. Okay, in this case, dependent variable Y is the house price, because the house price depends on the size of the house. Okay, and independent variables is square feet, since the size of house will affect the price of the house. Example, with the price 245,000, the size of house is 1,400 square feet. Okay, when the square feet is increased, example here to 350, so will affect the price of the house. So the price is higher than 245 when the size of house is increased. Okay. Right. So to solve this problem, the first step is we need to calculate the value of x times y, xy, and x squared. The price at the first column Y, and the size of house at the second column. So there are 1, 2, 4, 5, 6, 7, 8, 9, 10. There are 10 combination of house price with the size of the house. Okay, so the first step is we need to calculate the sum of Y, the total of Y, 245 plus 312 plus 279 until 255, you get 2865. And the sum of X is 1400 plus 1600 plus 1700, so on, and you get the total is 171550. So 245 times 1400, you got 343,000. 1600 plus 312, you got 499,200. Okay, 1700 times 279, you get 474,300. Okay, and the last column is the S squared. The S squared means 1400 plus times 1400, you get 196100000. 1600 squared, you get 2560000. And the sum is 30983,754 for X squared, and for SY the sum is 5085975. Right, now we go to the calculation of slope value. The slope value. So the slope value, the formula is the sum of SY minus the sum of X times the sum of Y over N divide the sum of X squared minus the sum of X squared. Okay, okay. See the bracket here. There is no bracket. Okay, over N. So the sum of SY from the table, we get 5085975. Here. The sum of X, we get 17150. The sum of Y, 2865 from here. Okay. 10 is the number of sample. There are 10 houses. 30983,750, we refer to last column, the S squared. Yeah? 30983,750. 17150 is the sum of X, and the sum of X, 17150 and squared. So be careful here. Be careful here because the bracket for the sum of X. This one no bracket. This one the sum of X squared. Okay. Divide by 10, so you get 0.109 for the slope value here. Okay. Right. B0 is the intercept value, which is we calculate using this formula. Y bar minus B1 S bar. Y bar is the average of Y. 2865 divided by 10. So you get 286.5. The S bar, 17150 divided by 10, you got 171.5. Yeah. Okay. 171.5. So finally, you get 98 98.2432962 for the intercept. Okay, for the intercept. So now you transfer into the predicted equation. You get y cap equal to P0, which is 98.248, the intercept value, plus 0.110 is the slope value you want X. This is the predicted regression linear model. Simple, for linear, simple. Right. So you can see, you can plot the straight line here, represent the linear, the linear regression model, and there are 10 points here, 10 coordinates here, represent the population of X and Y, population of X and Y. So this one, X, Y. So the interpretation of B0 and B1, the Y cap and the predicted equation 98.28248 plus 0.110x means no house have 0 square feet. No house have 0 square feet. Because from the graph, when x is equal to 0, means the square feet is 0, the price is 98,000. But here is only indicate that 98,000 is the portion of the house price not explained by the square feet. Okay. Second, we refer to the slope value. 0.110 slope value tell us that the average value of house is increased by 0.110 times 1,000. $1,000. So you got $110 on average for each additional 1 square foot of size. This is the meaning of the slope value that influence the result. So we go to the multiple linear regression. Okay. For multiple linear regression, the difference is the number of independent variables that we use to construct the predicted multiple regression model. Okay. So now we have K. We have K independent variables. K maybe 1, maybe 2 at least. 2, maybe 3 or more. Okay. Okay. So the minimum number of independent variables to conduct the multiple regression model is 2. Means the K is must more than 2. More than 2. Right. So since the individual random error of EI have a mean 0, so we don't use error in the question, in the predicted multiple regression model equation. So we can cut error. We assume that the mean is 0. So changes in Y, changes in Y predicted affected by changes in S1, S2, S3 to SK. Depends on the number of independent variables that we use. Okay, the least square equation. In order to calculate the slope value and the intercept value, so we need the formula, this formula for the slope, and this formula for intercept. But for this case, this formula is used for two independent variables only. Okay, so if you have more than two variables, you have to extend the equation. Okay. Right. So here the B1, the slope for B, the slope for the first independent variables S1 is given here. The sum of x2 squared times the sum of xy minus the sum x1 x2 times the sum of x2y. Okay, which is the sum of x1y is given by this equation. The sum of x2y is given by this equation. The sum of x1 x2, yeah, given by this equation. Okay. Then after you get the B1 and B2 value, so we convert into this equation to obtain the intercept value. Now we go to the example. Suppose we want to predict the job performance of Prodwell mechanic based on mechanical skill test and test score from personality. So there are two tests. Yeah? There are two tests that be taken by 20 staff. Yeah? There are 20 staff here. So the performance is measured here with the skill score test 40 and the personality score test 25. The first staff is labeled as 1. The performance is 1. Okay. For the skill score test 60 and the personality score test 34, the performance is labeled as 4, level 4. And level 5 for performance with the skill 60 score and personality test score 38. So record of performances with skill and personality score for 20 mechanics are observed as indicated in the table. So now we perform the regression analysis for the data observed. Okay. Okay, this is the solution. Look complex, more complex compared to simple regression. Simple regression, because now we have two variables, independent variables, which is S1 and S2, and one dependent variables. So Y represent the performance, S1 represent the skill, and S2 represent the personality. Okay, so we need to use this formula. We need to use this formula. Okay, so the sum of xy is given by the sum of x1y minus the sum of x1 times the sum of y over the number of sample. Okay, right. The sum of x1y, the sum of x1y. Okay, yeah. So the S1 40 times 1. So you get 40. 45, you times 2, you get 90. So on. So the total is 3513. Okay. The sum of S1, Y. Then the sum of S1 we refer to here. S1, first data 40, second data 45, third data 38, and so on. So you get the total is 1038. Yeah. Okay. And the sum of Y is 65. 1 plus 2, 1 plus 1 plus 3, so on, and you get 65. Divide by 20. 20 is the number of sample, the number of stuff. 20. So you get 3513 minus 3373.5, you get 139.5. Second question, the sum of x2y. x2y is given by the sum of x2 times y. Okay? x2 times y. Okay, the foot here. Okay, right. So x2 here 25 times 1, you get 25. 20 times 2, you get 40. Okay. 30 times 1, you get 30, and so on. So the total of x2 times y, you get 2219. Okay. Okay, 2219. Minus the sum of s2. The s2, the sum is 655. Yeah. Time the sum of y. The sum of y is 65. Yeah. Divide by 20, the number of sample. So you get 90.25. Okay. Last question. As the sum of s1, s2. S1 40, S2 25. So 40 times 25, you get 1000. 45 times 20, you get 900. 38 times 30, you get 1140. So the total of S1, S2 is 34510. Okay, 34510 minus the sum of S1. The sum of S1 is 1038. Yeah. And time the sum of S2, 655. Yeah. Divide by number of sample 20, so you get 15.5. So is the value of the three equations. Then transfer here. Okay. Right. So the slope value is given by this formula. Okay. So now the slope value for B1 is the sum of x2 squared. The sum of x2 squared. x2 squared here. Right. Which is 521.75. How you get this value? Okay. First, we get the sum of the x2 and the average for the sum. The average of the S2 is 655. Okay, 655 divided by 20, you get 33. So now 25 minus 33, you get negative 7.75. 20 minus 33, you get negative 12.75. 30 minus 33, you get negative 2.75, so on. Okay. Then we calculate the square of S2 minus S2 average. Yeah. Okay. S2 average. This is the average value. Yeah. Okay. S2 25 minus S2 average 33, you get negative 775. Negative 775 squared, you get 60.06. Okay. Negative 2.75 squared, you get 7.56. Negative 4.75 squared, you get 22.56, and so on. So the total is 521.75. Yeah. Okay. The sum of x1y we already calculate in previous slide here. Okay. Which is 139.5. Yeah. Okay. The sum of x1, x2. The sum of x1, x2 is 515.5. Okay. Okay. Time 90.25. 90.25, which is the sum of x2y. x2y. Okay. Divide the sum of 1 squared, which is 10918 here. Okay. We use the same step we use for x2. The first x1, the first data of x1, 40 plus 43 plus 38, and the total is 1038. Divide by 20, we get average 51.9. Okay, so 40 minus 51.9, you get negative 11.9. 38 minus 51.9, you get negative 13.9. So squared, squared, negative 11.9 squared, you get 14161. Negative 13.9 squared, you get 193.21, and so on. So the total you get 1091.8 to be here. And sum of x2 squared is 5 to 1.75 here. Already calculate. And the sum of x1, x2. The sum of x1, x2 is 515.5 times 515.5. Since we have squared outside the bracket. So we get this value 0.09. Yeah, this one 0.086 close to 0.09. Okay, 0.086409. Okay. So now we settle for B1. We go to B2. B2, the formula is the sum of x1 squared, which is 1091.8. Okay. Okay. The sum of x2 y, 90.25. Okay. The sum of x1, x2. Okay. And the sum of x1 y. This one. Okay. 139.5. Okay. The sum of x1 squared. Yeah. One zero 91.8, yeah, and the sum of x2 squared is 521.75, yeah, yeah, and the sum of x1 x2 squared outside the bracket, so 515.5, this one time 515.5. So you got this value for B2, 0.087. Okay. Then we transfer this value into intercept equation V1, V2. Okay. The y bar is the average of y is 3.3 or 3.25, two decimals, 3.25 minus the B1. The B1 is 0.086 times the average of S1 here, 51.9 minus 0.87 from here times the average of S2, which is 32.75 equals to 33. So we get negative 4.10. Okay. Then we already get the A value. The A value here, negative 4.10 plus B1, negative 0.086. Okay. And plus 0.087, okay, for B2. So this is the complete predicted regression model for multiple regression for two independent variables. Or you can also write as job performance equal to negative 4.21 110 plus 0.086 skill plus 0.087 personality. Okay. So we transfer into scatter plot. Is the y and y predicted. scatter plot predicted versus actual values. Okay, this is the scatter plot for y, s1, s2, and y. You can use Excel, Microsoft Excel, or SPSS or MATLAB also to generate the scatter plot. Also in 3 dimension, the 3 dimension is the graph we obtain. So that's all. So this exercise you can try and you can discuss the answer. That's all. Thank you. Assalamualaikum warahmatullahi wabarakatuh.